All right, we are ready to roll this morning, July 3rd, 2019. Welcome to this morning's farmdoc webinar entitled SREs and Biofuel Demand Destruction. And my name is Scott Irwin, and I will be the presenter this morning. I want to start with my baseline conclusions regarding SREs and biofuel demand destruction. And then basically my presentation will try to convince you that my conclusions are justified. So in short, here are my three main conclusions about SREs and biofuels demand. Number one, the SREs unequivocally have reduced RFS mandates substantially, billions of gallons. That's fairly straightforward to demonstrate. Number two, there has been substantial demand destruction in biofuels due to the SREs. But number three is, I believe that there's been negligible demand destruction for ethanol, and almost all of the demand destruction has fallen on biomass-based diesel. So the SREs, or Small Refinery Exemptions, have had a substantial impact on the biofuels industry, where I think my analysis probably differs from lots of people, particularly in the ethanol industry, is the distribution of the damage from the SREs within the biofuels industry in the US. So there you go. Those are my conclusions. And I wanted to state those up front as context as I work through my presentation. So let's start here. What I want to walk through is to make sure everyone is on a common understanding about exactly how do the SREs reduce RFS mandates. And again, not going to go into all the history of the SREs, the legal issues about how they are awarded and all of that. Just the straightforward arithmetic, if you will. So the top line shows how the percentage standard for the different RFS mandates is computed. It's rather straightforward. You take the gallon volumetric RVO and you divide it by total projected petroleum, gasoline, and diesel use after subtracting out the SREs. So, and that gives you the percentage standard for compliance that obligated parties under the RFS must demonstrate through turning in that amount of RINs after they have applied the percentage standard to their production and blending of petroleum, gasoline, and diesel. So here's an example. In 2017, the final EPA conventional standard, which is typically thought of as the ethanol standard, it was computed as 100 times 15 billion gallons divided by 180.13 billion gallons that was projected at the time of the final rulemaking for petroleum, gasoline, and diesel use. At the time that the final standards were computed, the EPA was projecting that SREs would be 0 gallons. So the math is straightforward. The final conventional percentage mandate was 8.32% based on those projections and a 15 billion gallon conventional ethanol standard. But what was the actual volumetric standard after obligated parties complied? So we look at the middle line under actual conventional RVO. we take the 8.32% from above and we multiply it by 166.9 billion gallons, and 8.32% of 166.9 billion gallons is 13.887 billion gallons, or 13.9 billion gallons. And in 2017, for the 2017 calendar year, that was the actual volume of compliance for the conventional ethanol standard. Now that can appear to be a bit of a head scratcher. The official rules said the standard was 15 billion gallons. But to comply, obligated parties only had to turn in 13.9 billion gallons worth of RINs. What gives? Well, here's what happened. In other words, why 13.9 billion gallons instead of 15 billion gallons? Under the Pruitt and Wheeler administrations at the EPA, and clearly under the influence of the refining industry, basically, you can view it as, if you like, a loophole in the implementation of the standards. The EPA has argued that once the percentage standard is fixed, in this example at 8.32%, it's fixed forever. We can't change that after we make the final rulemaking. It would be just too disruptive for people. And then what happens is retroactively, the EPA, after 2017, awards small refinery exemptions. And so you fix the percentage standard and then drop the base of gasoline and diesel use retroactively, and voila, you end up with actual conventional RVO of 13.9 billion gallons instead of what was on paper of 15 billion gallons when the final rulemaking was established. I've used a way of describing this as when in the last several years regarding the EPA's final conventional ethanol standard, what you see is not what you get. And so this is what's happened on paper. The exact same thing also applies to total advanced, the biodiesel, and the cellulosic standards. You get the same dropping of the mandates. Okay, so that's what's happened. And it seems like from this example that it ought to be obvious that if you're dropping the conventional ethanol standard from 15 billion gallons to 13.9 billion gallons, didn't 1.1 billion gallons of ethanol demand just disappear? And I really understand the logic of that. That seems like that would be a logical conclusion. But the data actually don't bear that out for the physical demand of ethanol. So here's where we have to separate basically what's going on paper with regard to RFS compliance versus physical markets. They're not always the same thing. Okay. So with that bit of background, here is the total reduction in RFS mandates due to SREs that I've computed personally. About 750 million gallons in 2016, about 1.8 billion gallons in 2017, and then in red, I have projections for 2018 and 2019, assuming basically the same percentage reduction in 18 and 19 as in 2017, because the SREs for 18 and 19 have not yet been awarded. And that's right now what's going on in Washington, D.C. Everyone's trying to figure out what those are going to be. And the Trump administration has announced that there is an internal White House review going on right now about what to do with the SREs. So it's important to remember as we go forward that the SREs have actually only been applied for the 2016 and 2017 calendar years. Nothing has formally been done yet for 18, 19, or 20. And maybe that's a way of understanding and emphasizing how big the political stakes are surrounding this White House review that's going on right now about SREs. Okay, so here's some further background about SREs. This chart shows the price of D4 biodiesel, D5 advanced, and D6 ethanol RINs going back as far as we have data into 2008. And what we see and what I want you to focus on is what's happened to RIN prices since late 2017. You can see in late 2017, all three RIN prices were around $1 a gallon and moving closely together. And since that time, that's about when the public information on the magnitude and changes in the SRE program were ongoing, we can see that this really collapsed RIN prices. There are other things going on that have contributed, but we can see that the D6 RIN price in red in particular dropped from just under $1 to back to under 10 cents a gallon for a period and has been hovering near 15 or 20 cents for most of late 2018 and 2019. And these are clearly, by a large measure, the lowest D6 ethanol RIN prices since pre-2013, when the mandates started to exceed the E10 blend wall, and we got into all the issues associated with breaching the blend wall. So clearly, when you reduce the mandates, and in particular, you're reducing the conventional ethanol mandate below the E10 blend wall, you collapse D6 RIN prices. That has happened. That's a fact. And that is largely, not exclusively, but largely due to the reductions in the mandate levels due to the SREs. That's happened. So what's happened to ethanol prices? This is a measure I use at Iowa plants on a weekly basis. And we can see that from the beginning, we don't necessarily see a pattern in the price in ethanol prices that matches the trajectory of D6 RIN prices. And again, that's because we know that ethanol prices are largely determined by corn prices, so we wouldn't expect RIN prices to track these precisely. But it's still interesting to see. We did see a drop-off in ethanol prices in late 2017, rose again, and then really collapsed in the second half of 2018, and now have climbed back above $1.50. It's important to keep this chart in mind as we move forward. So that's really the context in ethanol for trying to figure out what's going on in the physical ethanol markets as a consequence of these SREs. This has all so far been prices. The critical thing to look at, in my opinion, is rather than prices, what we really need to track is what's going on with quantity of ethanol. And that's what we really need to keep our eye on. And most particularly, we need to look at blend rates for ethanol. There are different ways to measure it. I'm going to show you two different measures of the ethanol blend rate. This is just simply different ways of computing the percentage of ethanol that's used in gasoline. Okay? This is actually the measure that I think is the cleanest and probably the most reliable, It's kind of got a long, complicated name, but basically think of this as on the numerator, we're measuring the amount of ethanol in a gallon of gasoline, if it contains ethanol, and divided by the total. And what you can see is really interesting. We've kind of crept up on this measure from just slightly above 10%. But what I really want you to see is look at what's happened since 2017. Remember earlier when the SREs hit, we really crashed D6 ethanol prices? There's no evidence that the percentage blending rate for ethanol has moved. It's virtually flatlined since about 2016. And intriguingly enough, on this particular measure, there's a slight uptick in this measure of the ethanol blend rate in 2018 and 2019 compared to 16 and 17. The next measure that I'm going to discuss of the ethanol blend rate is the one that the ethanol industry really favors, and there's some conceptual reasons for that. The numerator in this measure of the ethanol blend rate is monthly implied domestic consumption of ethanol. And the reason that we want to think about an implied measure of ethanol consumption is because some consumption of ethanol, particularly in higher blends like E15 and E85, occurs outside of the firms that are surveyed by the EIA to measure ethanol consumption. So this is a way that you can imply a measure of total ethanol consumption that includes, at least in theory, all potential sources of domestic ethanol consumption. Basically do the same thing on the denominator with finished motor gasoline supplied, and you divide one by the other, and you see, well, what's happening to the percentage of physical ethanol use in our total gasoline supplied. Let's take a look at that measure. I include the 10% line here again. That's our benchmark for E10 consumption. If everything was strictly 10% blends, that would be the amount of ethanol. That's what we would observe. This measure is a lot noisier and messier than the previous one because we're implying things. And so it's going to be more volatile. But what's fascinating is that basically it tells the same story as the previous measure. We did see this kind of anomalous surge in late 2017 and then a drop-off in early 2018, which a lot of people, including myself at the time, thought that that might be evidence of a physical market impact of the SREs. We now know that that's more likely due to just issues related to how ethanol exports get reported through the system. There's a lag. And what we really want to focus on is the blend rate for ethanol in 2018 and 2019. And so far, to date, if we just look at this on a year-to-year basis, there's really no evidence that the blend rate for physical ethanol consumption has changed over time. This measure, again, is noisy, but you can see on average, really very little change through this turbulent period of SREs. I like this chart in particular because it really summarizes things in a very clear way. So we can look at these are just the annual rather than monthly numbers. The ethanol blend rate was 10.02% in 2016 using this number. It was 10.14% in 2017. These are all pre-SREs. It did dip slightly in 2018 to 10.07% overall, but that was still higher than 2016. And so far, for the first 4 months of 2019, it's at 10.21%. So again, overall, there's just no evidence that I can find in the data that the physical consumption of ethanol in aggregate has declined due to the SREs. And so that's the data that I use to reach that conclusion. So now we get to a little economics. So hopefully your eyes won't glaze over at this point. But, there's a lot of debate, and I recognize that in particular, the ethanol industry has strongly disagreed with that conclusion. So I'll walk you through my arguments for why I think this has happened. You still have to explain a basic question, which it has been until very recently. Why have ethanol prices been so low if it's not due to the destruction of the physical demand for ethanol due to SREs? Well, here's the way that I take a look at that. This is a little supply and demand model that I use to understand the ethanol market. Let me talk our way through it. It's a very unusual looking demand curve. It's that we have a flat vertical section at the price of gasoline, which I label CBOB, which is the blend stock for most conventional gasoline. And my assumption is that ethanol, there we go. This is the flat section right here that I'm talking about. There's the price of gasoline. My assumption is that the break-even price of ethanol is equal to the price of petroleum gasoline. And the reason is because of ethanol's octane benefits in the blend. Ethanol is a relatively cheap source of octane, and this offsets any energy loss from blending ethanol. And my research says the break-even is right at around somewhere near the price of gasoline. So that means if the price of ethanol is equal to or less than the price of gasoline, that you will blend up to this vertical segment of the demand curve, which is the E10 blend wall, which I'm presuming everyone in the audience understand where that comes from. And so in this case, I've marked the typical situation for a number of years in the ethanol market, basically since around probably 2010, that the supply curve for ethanol intersects that vertical segment of the demand curve. So you get a price of ethanol below the price of gasoline. And so blenders want to use ethanol up to the 10%, which is for practical purposes, the limit in recent years. And the key implication of this model and the assumptions I use is notice that we'll use 10% ethanol so long as the price of ethanol is below the price of petroleum gasoline, because ethanol is competitive in the gasoline blend. And that is a very fundamental, important starting point in understanding my arguments. That means that any RFS mandate level up to the 10% blend wall is non-binding. Whether the RFS mandate exists or not, we're going to use 10% ethanol in our blends. And that's the model. So with that background, how could we end up with such low ethanol prices? Well, it's rather straightforward. In this way of looking at the world, we started here with this supply curve, gives you that price of ethanol. If you keep shifting out the supply curve, you keep getting lower and lower ethanol prices. Because the E10 blend wall, except for this very small part, which I allow for higher blends, when you shift that supply curve out, if productive capacity is increasing or something like the price of corn is falling, then you won't get any higher consumption of ethanol, you just get lower prices because physical consumption is effectively limited to the 10% blend wall. So let's take a look at actual annual U.S. production of fuel ethanol on an annual basis from 2010 through 2018. And what we see is that what I really want you to see is in 2014, we produced 14.3 billion gallons of ethanol. And then we went through a period of substantial expansion in ethanol production capacity of at least 1.5 billion gallons from the expansion of existing plant capacity and the addition of a few new plants. So we get to 2018 and we're now producing 16.1 billion gallons of ethanol, or 1.8 billion gallons, largely because we have expanded our capacity by about 1.5 billion gallons over this time period. And so my explanation for why the price of ethanol has been so low for most of the last 12 to 18 months is sitting right in front of you, that it's a supply story, not an SRE story. That's basically how I say there's been little, if any, demand destruction from the SREs in ethanol. Now, what about higher blends? I want to at least say a little bit about higher blends. This chart shows data from the EIA that they collect on ethanol blends greater than 55%. So this includes basically, this is their measure of E85. So we need to back up for a minute and recognize that even though E10, at least based on my model and assumptions, does not depend on a D6 RIN value to be competitive in the market, that's not true for E15 and E85. So let me repeat that. The level of RIN prices based on the model I showed you doesn't have any impact on our consumption of E10 because ethanol is competitive on its own. This is not true for higher blends based on economic theory and the data that I've looked at. So in theory, the SREs do have a negative impact through lower RIN prices on the incentives to consume E15 and E85. But the magnitude of that consumption is so small, it really doesn't show, that effect doesn't show up in our overall consumption figures. So I'll admit that some potential lost market share to E15 and E85 can be attributed to the SREs, but we're starting from such a tiny base of consumption, it really doesn't show up in the aggregate statistics. So here's the data that the EIA publishes, and we see that really we saw a surge in E85 consumption in 2018, probably due to really high gasoline prices relative to ethanol. And now we're kind of back where we started in 2017. So this measure doesn't really show and this still really does surprise me, doesn't show really any impact of the SREs on E85 consumption, which is a bit of a head scratcher to me. There's other data on E85 consumption that's collected through the Department of Revenue in Iowa and Minnesota Commerce Department, just for Iowa and Minnesota. And again, if we look carefully at this data from 2017 forward for these two states, maybe a little bit of an evidence of a drop in consumption there, but nothing that's really out of range. So even when we look at the physical consumption data for higher blends, we're not seeing the kind of impact of the SREs that theory would even predict. So that's my story, and I'm sticking to it on ethanol. And now I want to kind of speed through my arguments for why I think this is very, very important to reemphasize. When I say there hasn't been a demand destruction in ethanol due to the SREs, that does not mean that there's been no demand destruction for biofuels due to the SREs. And my argument is that the SREs have been highly destructive of biofuels demand overall, but almost all of it is hitting biomass-based diesel, which is what I use for BBD, the abbreviation I do here. A lot of people just use the term biodiesel, and that's fine too in this context. And so now I want to walk you through why I think that the vast bulk of the physical demand destruction from the SREs is occurring for BBD or biomass-based diesel. So this is my chart for a model that I use, supply and demand, to describe biomass-based diesel demand and supply, kind of a standard looking supply curve. And what we have here, ULSD, stands for ultra low sulfur diesel. You get a horizontal segment at that price. So without any mandates, biomass-based diesel, there's no demand below the price for ultra low sulfur diesel because it's not competitive in the diesel blend in the same way that ethanol is. And then this vertical segment represents the biomass-based diesel mandate under the RFS. And where that hits is, if that's the only mandate that biomass-based diesel hit, that would give you the price of biodiesel. But because of for a variety of reasons, biomass-based diesel not only can fill its own bucket, which is the BBD mandate, it has also tended to be what we call the marginal gallon to fill the rest of the advanced biofuels mandate. Okay, basically everything above think of the advanced mandate being above the biomass-based diesel mandate, and then that difference is also filled by BBD because it's the cheapest alternative among advanced eligible biofuels to fill that gap. Now, here's the one that I think there's a lot of misunderstanding about. In recent years, until the SREs hit, biomass-based diesel, or BBD, was also the marginal gallon for filling the conventional ethanol gap. In other words, if we had a conventional ethanol mandate of 15 billion gallons, and we could consume E10 up to, say, 14.2 billion gallons, there'd be an 800 million gallon gap. Now, it's certainly a very controversial point, and I understand not everyone will come to the same conclusions, but the data clearly show that for obligated parties, the cheapest way to fulfill the total obligations for the conventional mandate was to blend ethanol up to the E10 blend wall, in this example, 14.2 billion gallons, and then fill the rest of it with BBD. So this is the heart and soul of the story of why BBD has taken the vast majority of the hit from the SREs, because it fills three buckets under the RFS. The total requirement for full compliance with the RFS mandates in recent years, pre-SREs, would be well north of 3 billion gallons of physical biomass-based diesel. So a little bit about that. So I forgot to mention that it's the total of these three buckets that is the total demand for BBD, and it's that total demand that ultimately sets the price for BBD and biodiesel. So here are my estimates of how much total BBD physical demand has been reduced to SREs starting in 2016. So you can see about 350 million gallons in 16, almost 750 million gallons in 2017, and over 800 million gallons in 2018. I think that's actually around 900 million gallons projected for 18, and around 800 million gallons in 2019. So huge amounts of physical ethanol demand for BBD at stake due to the SREs in my analysis. And if you don't want to trust my computations, let's take a look at it a different way. In this chart, I plot what I call total BBD requirement or demand under the RFS pre-small refinery exemptions. And you can see back in 2014, it was a little below 2 billion gallons, and it was marching up in 2017. It was a little above 3 billion gallons, and for 2018, it was about 3.2 or 3.3 billion gallons, and in 2019, it's about 3.4 billion gallons. Notice the pattern here. 14, 15, and 16. The refining and obligated parties for the RFS were incentivizing BBD production at an ever-rising pace in anticipation of that requirement stair-stepping up over time. Now, clearly in 2016, there was even more production going on because the BBD $1 a gallon tax credit was in place, and that further juiced up incentives to produce in 2016. But the overall pattern is there. Then in 2017, we start getting the SREs, and look at where BBD RIN generation went relative to the pre-SRE production requirements. And basically, the way I like to look at it, by 2016, obligated parties under the RFS were clearly anticipating an annual need for at least 3 billion gallons of BBD for compliance. And since then, they have been incentivizing BBD production more like 2.5 billion gallons. So at least a 500 billion gallon a year loss in physical demand for BBD due to the SREs. I think on average, probably even bigger than that. So I have some estimates of the economic magnitude of the damages and different ways to compute them. but it's in the billions of dollars. And I think that's what's important to emphasize here. And finally, I want to end with a point on where all of this might be going. We now have suddenly a White House review of the entire SRE programs, but we also have rattling around the court system's challenges to the SREs. And I just want to make one point that I've made for a while now, is that the way the SREs are being applied by the EPA, I believe, fundamentally are in violation of congressional intent for the renewable fuel program as stated by the U.S. Appeals Court and Judge Kavanaugh in his decision in Americans for Clean Energy back in July 2017, that the RFS was intended by Congress to be a market forcing policy that would create demand pressure. And so fundamentally, going back to the very first slide of my presentation, when you have a procedure that retroactively cuts every year the mandates below what Congress intended, you can't have a market forcing policy. So I think there's a fundamental contradiction there, and it'll be interesting to see how courts subsequently rule on that particular issue. You can see on this slide my smiling picture, and there's my email address. You can send me questions via email, and I'm also really active on Twitter. My Twitter handle is @scottirwin.ui, and you can also see our archive of videos at our YouTube channel. So with that, we're going to sign off today.